the sign oxidation numbers. So the thing you got to be really cautious of here is to recognize that you need 2 ammonias to form 1 molecule of N2, which means 1 nitrogen atom isn't being oxidized. 2 nitrogen atoms are being oxidized. So simplify this reaction to make your balancing in the next step easier. The same will be true here. So here we'll need 2 nitrogen atoms to become 1 nitrogen molecule, right? Because there's going to be 2 nitrogen atoms here. We'll need 2 of these to form 1 of those. So in this case, to go from +4 to 0, this is going to be 8 electrons gained. So let's just leave this part to the end. If we've got 6 lost and 8 gained, we're going to need 4 of these reactions and 3 of these reactions. So times 4 times 3, there you go. Okay, so if this one was times 4, 4 times 6 electrons lost, that's 24 electrons lost. This will be, let's see, times 3. So now we've got 24 electrons gained. And so this is what, 8 plus 6, 14. So then this would be 7 for the 14 nitrogens. And all that's left is to balance the water as we would normally. So we've got 24 hydrogens, 12 oxygen, boom, 12 oxygen, check, in the can. You know what, here's another method, because there's more than one way. Let's show the other way here. If we were to look at this reaction again, so we got NH3 plus NO2 forms N2 plus H2O, we could recognize our half reactions just like before with all those oxidation numbers. But instead of trying to balance it all at once, we can split it into 2 half reactions. So if we recall, this was, let's see, -3 plus 1 plus 4, -2, 0 plus 1 minus 2. Okay. So we can balance this as we would normally. Okay, we'll need 2 nitrogens. When we go from -3 to 0, we're going to lose 6 electrons. There you go. To balance this out, we can assume acidic conditions. With NO2 and N2, again, this has to happen twice. We actually need 8 electrons to combine with these 2 NO2s to form an N2. We've got 4 oxygens. This is 4 H2Os, 8 H+. So for balancing under acidic conditions, this is how it would work. These are balanced half reactions. Now all we have to recognize now is that we got to balance out these 2 values. So we're going to multiply this half reaction by 4. We're going to multiply this half reaction by 3 in order to get 24 electrons lost for every 24 electrons gained. Let's work out the math on that. So we're just going to distributive property these. So we've got 8 NH3 forms 4 N2 plus 24 electrons plus 24 hydrogen ions. So here we've got 24 hydrogen ions, we've got 24 electrons, 6 molecules of nitrogen dioxide, 3 molecules of N2, 12 molecules of O. So we're going to add all the reactants together, we're going to add all the products together. Now what we can do ahead of time is we can recognize that if we start and finish with this many protons, it didn't really participate directly in the reaction. we start and finish with that many electrons, and they cancel. Okay, that works. Now, let's add it together. What do we got left here? We've got 8 NH3 plus 6 NO2 forms 7 N2